Guys, for our today's agenda is to know about the Microsoft Azure Serverless Computing. We will have a look in this class that what serverless computing is and what Microsoft Azure Serverless Offering does have to provide us for our better facilities. So let's have a quick look at what is serverless and why do we need serverless computing or serverless databases. So what the serverless computing is? So serverless computing is basically a computing that will allow your developers or your application builders to just focus on the application code and business rather than worrying about the underlying infrastructure. So let's say you have an application that you have built and you want it to be user accessible. What will you do? You will need a server for that. An application needs to be run on the server. The dependencies for an application to run on is can be a physical server or a on-premises server or a cloud computing server as well. So what serverless computing is that basically serverless computing offers you a solution that will involve no overhead of managing the servers as well. The serverless computing is a cloud computing model where the cloud providers takes the responsibility for managing the infrastructure and automatically allocates resources based on demand. So as the name suggests, serverless computing. So now one question arises in mind is that is serverless computing actually serverless? So the answer to that is no. There is no such thing. There is no such solution that we can actually provide to the customers that where there is no actual server present in behind and your application is running on. There is no possibility that your application is just running on abstract and just running on in air. There are servers present, but why we call them serverless is that because they are fully managed by the cloud providers. They are, in our case, they are fully managed by Microsoft Azure itself. We do not have to worry about the servers. We do not have to worry about scaling them up or down according to our needs. Everything will be fully managed by the Azure Serverless Solutions itself. So let's have a quick look at what traditional computing had to offer us and why serverless computing is better. So you will be able to have a complete understanding of what serverless solution is and why you should go with the serverless computing. Using the traditional servers, you will have to pay those extra server that you have utilized. But in the serverless computing, that is the beauty of serverless computing. You will only be charged for the resources that you are actually using. You are not being charged for the resources that are sitting idle, that are going waste. You do not have to pay a single penny for that. So as we have discussed previously that why we use serverless computing, it just clears the picture that why not, why should we not use serverless computing? Because it has a lot of benefits. It will reduce overhead. When there is no need for developers to maintain the infrastructure, to maintain the resources, definitely it will be improving the performance. And about the scalability, that is one of the key aspects of the serverless computing, is that we can scale our application up and down on demand. Let's say if the application scope increases, the number of requests that our application is getting, that is increasing day by day, it will automatically scale up our resources. And when at some point in the life cycle of our application, the requests have started to come down, it will scale down our instances. Now, definitely when your developers are 24/7 working on the things that are not based on the infrastructure, you will definitely have a faster time to market. Now, when you have your application faster time to market, it definitely increase the agility and the performance. Now, how does it increase the performance? Definitely, we have seen the benefits. We have seen that we will not be paying any of the attention to the servers that we want to scale up our servers if you want to scale down. So when you're only focused on your business, when you're only focused on your application and customer user interaction, then you will definitely have a lot of improved performance with Azure Serverless Computing. So let's have a quick look at what serverless offering does Microsoft Azure has to provide us. Now, Microsoft Azure has a bunch of serverless offerings that to offer us not in the terms of only of the compute and not in the term of databases, but in other business aspects as well. We have Azure for serverless Azure functions, where we can just deploy a piece of code and that's it. We get it up and running without managing the infrastructure. We have Azure Logic apps for our serverless workflow. We have Azure Event Grid that just allows developers to react to the events from the various resources in real time. We have Azure Cosmos DB and we have Azure Container Apps. We will have a look at that in the next upcoming slides because our masterclass is based on Azure Container Apps. So let's have a quick look on the compute resource services that Microsoft Azure has to provide. So you have, first of all, that there is serverless functions. Now, what serverless functions is a compute service that allows our code to run in a serverless environment. We just write the piece of code in our desired language. Let's say Microsoft provides the integration for a C hash. You want to write your code in PHP, Java, Python. You can write your code in the desired language and you put it on the serverless function and it is there. It is up and running. Now, if we have our containerized applications, let's say our application is containerized. Now, what we have the solution for serverless on Azure, it is Azure Kubernetes service that is basically called as AKS. Now, what AKS does, it provides an orchestrating environment for your containers that scales up and down according to your needs. And then last but not least, we have Azure Container Apps. Now, Azure Container Apps is the serverless offering by Microsoft, fully managed serverless offering by Microsoft Azure that is specifically used for our containerized application and microservices. Now, for the microservices, we have a third-party integration with that as well. That is distributed application runtime just for our microservices to talk to each other. We have this integration, and then we have an Kubernetes event-driven auto-scaling (KEDA) to scale our application, to scale our containers, whether vertically or horizontally, because behind the scenes, Container Apps is powered by the Kubernetes itself, and we will have a brief look on that in the upcoming slides as well. So now Azure is not only restricted to the compute services, Azure also have some database serverless services as well. We have Azure SQL database service and we have Azure Cosmos database service that runs our instances according to the customer needs, that when the request units to your database has increased, it will scale up and gradually scale down when there is no request. And we will have a quick look at that. That will allow you to understand more on what I tend to make you understand here is that. Now, as you can see in the graph, that whenever the request to our CPU usage, when the request to our database is increasing, the instances has been increasing as well. Let's say that in the from 11 a.m. to 12 a.m. or something like that, our requests have been going up. So it is literally scaling our instances to the according to on demand. So let's say we have an inactive phase. What the serverless capabilities are used here is that when your application is in inactive phase, when there is no request coming, it will scale your application instance to 1, and then it will check that, okay, whether any request is coming to it or not. It will stay up for some time, and when there is no request, let's say in at 1 a.m. or 2 a.m. in the morning, that there is no one using your application, what happens is that it will literally scale to 0, as you can see here. So this is one of the beauty of the Azure Serverless database as well, that you will only pay for the uptime of your application. You will not pay anything for the inactivity or the paused state. So
Ahmad, Sujit Wagis has a question. He's raised his hand.
Okay, sure.
One question regarding both the variants of database. This feature is not available for the regular database. I mean, there was Azure database and this Cosmos. So this pause functionality is not applicable for the other one.
Okay, so as you know, that Azure has to provide a lot of the offerings that we have separate offering for MySQL Server. Now, this is specifically for the serverless Cosmos DB. Hello?
Okay. Okay, that means the other one, this feature is not available. That's my
Yes.
understanding correct?
No, this feature is actually available. Yes.
Yes,
I mean,
so basically whatever the serverless computing we will be using, so as if there is no request, it will anything which is serverless, it will go to inactive state and will be saving our cost.
Okay, clear.
okay, Prakash, can proceed.
Yes.
Okay, so let's continue the session. So let us discuss that what Azure Container Apps is, and our today's agenda is basically more emphasized on the Azure Container Apps. So what Azure Container Apps is. Azure Container Apps is a fully managed environment that enables us to run our microservices and containerized applications on a serverless platform. The common uses of Azure Container Apps is that it includes that we can deploy API endpoints, we have hosting, background process applications, we can handle the event-driven processes as well. Now, for the Azure Container Apps, we have different scaling options. Let's say, as we know that Azure Container Apps is a serverless offering, so definitely it will have some triggers, it will have some things that we will basically scale up our application and scale it down. So what are those factors that basically scales up our resources? They can be based on the HTTP request that our application is having. We can have some event-driven processes. We have that some CPU or memory load is has been increased, so it will definitely increase. So if we have the containers that have to be scaled up, we have the KEDA, that is Kubernetes event-driven auto-scaling supported scaler as well. So as we discussed that Azure Container Apps is basically also powered by the Kubernetes. So we will have a brief look at what Kubernetes is. So Kubernetes is one of the powerful container orchestrating tool. As we know that the demand of the containers, as organizations have decided to go with the containerized application, have decided to go with the microservices. Now we needed some platform that where we can handle our containers, where we want to manage our containers in a perfect manner. So we have Kubernetes. Kubernetes is a container orchestrating tool that will basically scale your containers up on in demand and scale them down. With the organizations adopting it 61% of the worldwide. Now, what are some of the key benefits of the Kubernetes? It has some automated scaling that we have. It will scale up and scale down our resources. We have also end-to-end developer productivity with debugging and CI/CD integration as well. We have a secure advanced identity and access management to monitor and maintain our container security. And definitely Kubernetes have some integration with support for Linux and Windows servers as well. So now the question arises that why should we consider Azure Container Apps? Now let us discuss that when there is no container apps in the picture, what happened is that when I wanted to deploy my containers, we have container instances and up to we have running the Kubernetes on virtual machines. Now, as it was the previously container instances, we have it was a simpler approach to go with, but we had less flexible and fewer options as when we moved from app services to running the AKS cluster as your Kubernetes service and running our Kubernetes on virtual machines, as it got more flexible with more options, it also got more complex. Now managing a Kubernetes service, a Kubernetes cluster by yourself that when it is running on Kubernetes virtual machine can be tedious and complex sometimes, and managing some of the Kubernetes cluster as well can be tedious sometimes as well if you are hosting your application on AKS. So here it is when container apps come into the picture, that we want an intermediary solution where we can have more options of flexibility, but we want to have a less complex infrastructure to manage, less complex Kubernetes server. So let's say what container apps does is container apps basically reduces reduces the overhead to manage our KAS cluster, but it is powered by, as we know that it is powered by Kubernetes event-driven auto scaling. We have Kubernetes underlying, but we do not have the full access. We do not have to fully manage the Kubernetes cluster. It will be managed by Microsoft Azure itself. So what are some key benefits of the Azure Container Apps? Definitely, as we previously discussed, handling a Kubernetes cluster can be somewhat tedious, and let's say you do not have a very experienced resource to manage your Kubernetes cluster, but you still want your application to be up and running. Azure Container Apps is the option there for you to get started. You have auto scaling with greater depth, as it is powered by Kubernetes event-driven auto scaling. It will definitely scale your instances according to the customer needs. We have blue-green by default. We do not require any downtime for our application. Even it is serverless, we do not have any downtime required for our application. Now, as it is powered by Kubernetes, we have somewhat access to our cluster. We will get to that in a moment where we can see that how much replica counts we want, how much vCPUs count we want, the things like that we can also manage with the Azure Container Apps. Now, one of the most intriguing perspective for the container apps is that how it is priced. Now this is very interestingly priced by Microsoft Azure. Now this is the official pricing that Microsoft Azure has to offer us. So we are basically charged on the basis of in the aspect of virtual CPUs, we will be charged on the basis that 180,000 seconds of our CPU usage per month will be free, and 360,000 seconds of our memory usage will be free. And if we go over that, we will pay $0.000024 per second over million. So container apps basically is built combined on the number of requests that our application receives. So the free grant per month that Microsoft Azure Container Apps has to offer is 2 million. The first 2 million requests on each month on our application will be free, and if we go over that, we will pay according to per million, and that is, you can see, very less price of $0.40 per million. So it is a very good and flexible pricing that Microsoft offers us. If anyone wants to get started with the microservices and containers deployment, you can easily get started with the Azure Container Apps without without worrying about that it is going to cost you big time. No, it is not going to cost you big time, as you have seen that how flexible our pricing model gets with Azure Container Apps. So let's have now to understand everything, it is important to have a scenario where we can compare our two resources, where we can actually understand that what is happening in real time. So let's say you have an application, you have an e-commerce application that is of the intermediate level, that it is not of the business level application. It is an application that receives over 100,000 or 200,000 million requests, 200,000 requests per month. Then what will you do? Let's say in this scenario, we can use basic plan for Azure Container Apps. Let's say we are using our minimum resources, or we are using 1 vCPU and 1 GB of memory, and the pricing for the basic plan is $0.017 per hour. And if you have 2 replicas that are up and running continuously for 30 days, now what happens? What with your pricing model is that it's cost you $24.48 per month. Now, definitely, we will not be. That is one of the key aspects of the Azure Container Apps, that we will not be running our containers 24/7 for the 30 days, because their application definitely will have some inactivity phase when there is literally no request coming to your container, and it will get even less than that. Now let's say you have a containerized application and microservices deployed on Azure Kubernetes service. Now here we are talking about the application that has not a larger scope, that has an intermediary scope. And let's say you deploy it on AKS. Now what Azure Kubernetes Service Serverless will have, it will give 100% uptime. That means 100% uptime means that basically your replicas and servers are running 24/7 and they are running at any time of the day. And you have two replicas, let's say with the smaller instances on the Azure Kubernetes service, it will cost us $52.56 per month, as it is an imaginary calculated scenario. So you can see some of the price difference from that when we move our intermediate application from AKS to container apps, it will definitely help you save some cost. So as we know that dev test workload, dev test environment is very important for any organization. We have our developers and testers working on some application for its better productivity for the users. Now, Azure Container Apps can scale up or down automatically based on the workload demands. Now, what happens is that this will help you avoid the over provisioning and ensures that you are only paying for the resources you actually need. Now, with the Azure Containers unique feature that is basically called auto scaling to zero means that if no one is using your dev test environment, the container apps, we can see it literally scales down to zero. Let's say your developers are working from 9 to 6 p.m. Now what happens? They will only be paying for the resources when they are using. Here you can see. But when there is no traffic, no one is using your application, when no developer or tester using the application, it will literally scale to zero and you will not be paying a single penny for the instances that have scaled down to zero. So any questions till that? If not, then we can proceed to the lab.
No, so we have a question in the chat by Mr. Kabir.
Okay.
So please give us some details on Azure bots for one-level recurring tasks.
Can you please repeat, Prakash? I was not able to clearly understand.
Yeah, sure. Please give us some details on Azure bots for level 1 recurring tasks.
Yeah. So let me take this, Prakash. So Kabir, yes, what we can do is we can, have a planned dedicated session on this, conversational boards and how we can use those virtual agents in our applications. So currently for this, we have confined this to the serverless offering, but let's plan for a session. We can reach out to you and we can, get more detailed level conversation regarding this boards and how it can improve our board application, or if we want to create some models, that is something we can discuss.
Okay.
Yes. So let us.
Yes, Sujit, you have raised the hand. Please proceed.
Yeah, in the previous slide, you were showing the costing regarding apps as lower versus the other AKS as higher cost, right? Not in this one.
Mm-hmm.
Yeah.
What is the difference like in terms of why the AKS part is costing goes a bit higher?
Okay. Okay. So what happens here is that when we have deployed our application on Azure Kubernetes service, now, as you know, that our pricing model gets utilized according to the resources that we are using. So what happens in Azure Kubernetes service is that we have 100% uptime, as you can see, that our instances are not going to zero even if we do not have any traffic coming to our Kubernetes cluster, right? Like there is no traffic at, let's say, at 1 a.m. or 2 a.m. in the morning, but our servers are still up and running. So the main difference between the Azure Kubernetes service and Azure Container Apps is that when there is no traffic coming to Azure Container Apps, it will scale your instances to zero, literally scale to zero. So when there are no instances up and running, we have scaled our application to zero. We will not be paying for those resources. But in opposite, in AKS, whether we having our application is receiving some traffic or not, it gives us 100% uptime for that. So that is the key difference between AKS and Azure Container Apps. I hope that answers the concept.
Yeah, thank you.
And
Yeah.
also, Sujit, in container apps, we have, let's say, options available where we can choose even 0.25 vCPUs and
Yes.
0.5 GB of RAM. But in the AKS, if we go with the virtual machines, we can go with the minimum one. So, but in container apps, we can even have the lesser specifications for our containers.
Yes, we will get to that in a moment, Haris, as well, when we deploy our application.
Thank you.
Yep. So should we proceed to our lab and let's have a quick look at how an application is deployed to the container apps?
Just a few seconds to everyone. Please feel free to ask questions either in the chat or on the call. We're happy to pause and then take that up.
Sure.
So no questions. So okay, I think we can continue, Ahmed.
Okay, thank you, Prakash.
Okay, there's some question that has come
Okay.
from Carl Denver. Is this webinar have certifications? No, unfortunately, but I think we do have a plan on that side, Carl. So after the masterclass, happy to take that question, answer that question on a one-on-one call. Okay. Thank you. Over to you, Ahmed.
Okay, thank you, Prakash. So guys, let's have a quick look at how we can deploy our application to Azure Container Apps. Now, as you can see that I have navigated to my Azure portal. I'll click on the Container Apps, click on Create. So this is the Azure Container Apps options that you can set for your container apps. Let's say you can use subscription, whatever subscription you have access to. Let's say in this case we use MPN Dev, one of the subscription that we have, and the resource group. Let's say we use a resource group, and you can name your application according to that. Let's say I name it ecom, and we have option to select our region. Right now I have selected UAE North for the low latency. You can select according to your required need. And so we can have a container apps environment. Let me briefly tell you what container apps environment is. So let me create. So what container apps environment is? So basically container apps environment basically houses your configuration for your container apps, just like the resource group. Now in the Microsoft Azure, resource group houses our resources, that whatever resources we have deployed, we have to house them in a package called resource group. So similarly to that, we have Azure Container Apps environment. Let's say I have a multi-containerized application. There is one or more containerized, and I want to use the same environment. I cannot go on and make a new one, but I can use the previously existing one. So let's say we name anything our environment. Let's say we have Masterclass, ENV. Okay, then we have monitoring. Now we have log analytics workspace. Now what log analytic workspace is for, basically storing our application logs, where we can see the application logs easily. So we can use the existing one, we can create a new one, just name whatever you want to name it. Let's say Masterclass log. Say okay. And for the networking part, now this is a very important part that you have to look now, that we Azure Container Apps allows you to use your own virtual network. So if I click on yes, we have definitely we have a VNet that our resources have been deployed to. So for that purposes, you can select your virtual network. If you have created, for right now, I will be going with the no, but you can also deploy your container apps in a specific virtual network of your need, of your choice. Let's say create. Now this will create our environment. Now let's move on to the app setting. Now by default, Microsoft Azure, for your better understanding and helping of the container apps, gives you a quick start image as well to use. It's a Hello World container, but for today's lab session, today's purposes, we will be using our custom image or custom repository. So we can have our images from Docker Hub, or we can have our images that we have pushed to Azure Container Apps. For these purposes, we have pushed one Docker image to our Azure Container Registry. So we will be selecting that. As you can see, ecom ACR. So let's say we have one image that has been uploaded. It's ecom app 001. Let's say we have the tag, select latest. Now, as one of the guys, as Haris answered one of the question about regarding the CPU and memory usage, we can see that we can allocate our container resources. Like here, you have a bunch of different options according to your application scope that you can select. You can go with the 2 vCPUs, and these are the options that your replicas will be running on. So for now, let me go with the minimum resources. Now we have application ingress settings. Now, as if guys are familiar with some Kubernetes, you can see that what ingress is. Ingress is basically used to allow your application to receive some traffic from internet. So we have ingress options, as we studied for the container apps, that we have some access to our underlying microservices. So this is one of them. You can limit it to container apps environment only, or you can limit it to accepting traffic from anywhere. It will basically allows the internet to access our application. From the internet, we can access it. So we can enter the desired port here. Let's say it's 80. That is the port that our container will be listening on. Let's go on to tags. Here we can assign our tags according to the resources we want, but for now I will not assign any tag to that. Review and create. Now it will run some validation here, as it says running. So as yes. So let me create. So what happens is that will create one of our container apps environment where our application is hosted, right? So for that purpose, this was the purpose to show you that how the deployment is done. Definitely, if we wait for that, it will take some time, 10 to 15 minutes. But for you, we have already in a similar manner, we have deployed one of the e-commerce application for your assistance, just because to keep it short and interactive as well. Here I will navigate to my container apps. I will select my sponsorship that we have. Now here you can see that our e-com container has been deployed that we are using for our today's purposes. So one or two things that we have to manage here. That first of all, this is the application URL, right? If I copy this and paste it into this, you can see it is very tedious. I do not want my application URL to look like that. It's quite a verbiage here. I want a simple and comprehensive URL. So for that, we have custom domains here as well. So we can add our custom domains as well here. That here it is ecom TecBrix. Now let me copy and paste. Go. So yep, here we go. So this is our e-commerce application that we have hosted. So let's talk about the metrics that we want. Now metrics will help you understand that one of the question our guy asked, that what is the difference between Kubernetes and what is the difference between Azure Container Apps, that how it is pricing a little bit less than Kubernetes service. So let's say I can select my metric according to the CPU usage. So as you can see that when there is traffic coming, it is our instances has scaled up. But when there is no traffic, let's say there is not a single traffic coming to our app, sample app, we can literally scale. It says, you can see here, it scales to 0. You will not have any of the inactivity phase running, and when there is an inactivity phase, there is no CPU running. You can clearly see that. Now, according to the CPU usage, we can also see that how our replica count is working, how our containers has basically scaled up. We can see we can click on replica count, and it will show you that how, according to the CPU, your replica count has increased. So as you can see, when there is no traffic, when it is in the inactive phase, the replica count has scaled to 0, but when some traffic came, it scales to 1, and it has scaled up to 6. So it has scaled up to 6. So we can also control that. We already told you about that, how we can have still a little bit of management from the Azure Container Apps. You can still manage your replica count. You can here deliberately select that, okay, I want my replicas to, you can either go up to 30, and you can even restrict your Azure Container Apps to even go to 1. As you can say, this is one of the key perspective of the Azure Container Apps that they have to provide us. So let's go back. Okay, so we also have continuous deployment thing going on with the Azure Container Apps. We will discuss that in hopefully in the upcoming sessions. So let's come back to our e-commerce app. So let's say if you want to have an admin access, you just type /admin, enter, and here we go. We have the admin dashboard where we can see our categories. We can delete and add our products. We can see of the what orders we have. We can see about the pricing. We have different sidebars that is here. So that is the thing that we have hosted our e-commerce application on the Azure Container Apps. So you can also copy this application URL as well, so it will go to the same pages too. Yep. So over to you, Prakash. That's it from the lab side. If the guys have any questions, they can ask.
Thank you, Amit. Thank you very much. It was a fantastic session.